Hello and welcome. So we are going to continue on lesson 13. Okay, so lesson 13 is about inserting rows. Okay, we have spent quite a few lessons on how to query for data in a database. So it's time to start learning a bit about SQL schemas and how to add new data. What is a schema? We previously described a table in a database as a two-dimensional set of rows and columns, okay, with the columns being the properties and the rows being instances of the entity in the table. In SQL, the database schema is what describes the structure of each table. Database schema, structure of each table, okay, and the data types, okay. For example, in our movies table, values in the year column must be an integer, and the values in the title must be a string. Okay, this fixed structure is what allows a database to be efficient and consistent. Okay, inserting new data. When inserting data into a database, we need to use an insert statement which declares which table to write into, the columns of data that we are filling, and one or more rows of data to insert. In general, each row of data you insert should contain values for every corresponding column in the table. You can insert multiple rows at a time by just listing them sequentially. Oh, we are inserting new data. Okay. Insert into this table. What is the value? Value, another value. Oh. Each row of data you insert should contain values for every corresponding column. Oh, so if you have like, 5 columns, so we have five values. At least, I think. In some cases, if you have incomplete data and the table contains columns that support default values, you can insert row with only the columns of data you have by specifying them explicitly. Insert into certain column the values. Okay, in these cases, the number of values need to match the number of columns. Okay, despite this, inserting values has the benefit of being forward compatible. If you add a new column to the table with a default value, no hard-coded insert statement will have to change as a result to accumulate the change. You can use mathematical and string expression and be useful to ensure that all data inserted is formatted a certain way. Wow. Exercise. Right, let's go. In this exercise, we are going to play Studio Executive and add a few movies. Okay. Disable, the ID is an auto-incrementing integer, so you can try inserting a row with only the other columns defined. Alright. Since the following lesson will modify the database, you will have to manually run each query once they are ready to go. Modify database. What are we going to do? Add the studio's new production. Okay. Add the studio's new production Toy 4 to the list of movies. Okay, so how do we add? Insert what? Right. Okay, wait a minute. Do we need to write it before the select? Yes. Okay, so insert what? Insert into you can use any director. Oh, you can choose the director. Insert into movies. Is that how we do it? Insert into movies. Insert into movies and values or insert into movies, values, yeah, insert into movies, or is it movie? It's movies. Okay, what values? What is the values? Toy Story 4. Toy Story 4. Okay. Then Toy Story 4 for the title. Then just choose the same table. Director is going to be John Lasseter. Then John Lasseter, year is when? This year, 2024. 2024, and length minutes. Minutes is going to be 90. Okay, 90. Yeah, just like that. Run query. Incomplete SQL query. Oh no, how do you use this? Because the values, like, insert into. Okay. We need to make it capital or what? Why do we not have the values to be blue? It's a statement with values for all columns. How do we make it as a keyword? It's not working. It is not working. Did I do something wrong? Is there something wrong? Why is the into not blue? Inside the database, since the following lessons will modify the database, you'll have to manually run each query once they are ready to go. At the studio's new production. Okay, I'm stuck right now and I'm not sure what to do. This is very bad because we have an incomplete SQL query, right? We don't know how to fix it. Seriously bro, seriously man, why isn't insert into working? Like why is this not blue? I need to refresh the, let's try it under insert into movies. Nah, into is not blue. This is making me feel bad. Insert into box office. Insert into movies. Copy this. Paste. Insert into movies. Insert into movies. Why? Movie ID, rating, sales in million. We are going to add the title, then the director, and the year, and the length in minutes. Alright, then the values. Why isn't it blue? It's not becoming blue is a problem already for me. Values of title will be Toy Story 4. Then you can just put it in one. Toy Story 4. So one bracket is for one row. For Toy Story 4. Next is the director, John Lasseter. John Lasseter. Then year is 2024 and length minutes is 90. Simple. And it's still not working. Okay, let's see the solution. Oh, so we need to put it in string. Damn it. I see. Toy Story 4 has been released to critical acclaim. It had a rating of 8.7 and made 340 million domestically and it recorded to the box office table. Add the record to box office table. Okay, this time we should do it correctly. So insert into box office values for rating of 8.7, 340 million domestically, 340 times 1 million. That is so much work. 340 million, yeah, I think that's better. 1, 2, 3 and 270 million. That's better because I'm gonna be confused. Yeah, nice. On to the next lesson, lesson 14. In addition to adding new data, we are going to updating rows. Common task is to update existing data, which can be done using an update statement. Similar to the insert, you have to specify exactly which table, columns, and rows. In addition, the data you are updating has to match the data type of the column. Set update what table, then we set what the column, then the condition. The statement works by taking multiple column value pairs and applying these changes to each and every row that satisfies the constraint in the where clause. Taking care. Most people working with SQL will make mistakes updating data at one point or another. Whether it's updating the wrong set of rows in a production database, or accidentally leaving out the where clause, which causes the update to apply to all rows, you need to be extra careful when constructing update statements. One helpful tip is to always write the constraint first and test it in a select query to make sure you are updating the right rows, and only then writing the column value pairs again. Some of the information in our movies database might be incorrect, so go ahead and fix them through the exercises below. So we need to query first, right? That's the workflow, I guess. Recommended. The director for A Bug's Life is incorrect. It was actually directed by John Lasseter. Bug's Life, El Directore. I see. El Directore again. So we need to somehow get the director of Bug's Life. Select director. No, we don't have any constraint, right? So yeah, I don't think we have any problems to find. So we don't need any condition, if I'm not mistaken. Or maybe there is. The ID is equals to 2. So update movies, then set column equals to value, director equals to John Lasseter. For which row? For the row that is with ID where ID is equals to 2. Yep. Wait, is it wrong? Oh no. Is it wrong? Oh, come on. Seriously? Is this not how we do it? ID is equals to 2, right? What is the problem? Select all from this. ID is equals to 2. Oh, it's correct now. It's correct. It's correct now. But why are we not passing? Because we made a typo. Seriously, what did I just do? Okay, we just Control Z everything and run it. The double S. Okay. I don't know, man. Last setter. Okay. The year that Toy Story 2 was released is incorrect. It was actually released in 1999. Okay, so we need to be very careful, very extra careful when typing. So we should copy paste. Shouldn't type it up. We shouldn't type it up. The year that Toy Story 2 was released is incorrect. It was 1999. Oh, yeah. So update movies, set what? Set year equals to 1999, where the ID is equals to Toy Story 2 is 3. Or maybe we can shoot no, I think that's fine. Okay, both the title and director for Toy Story 8 is incorrect. Okay, so we need to replace two things. Update from this, set okay, what column? The director and the title equals to Toy Story 3. Okay, correct spelling. Then we need to change the director also. There is going to be Lee Unkrich. Lee Unkrich. Alright. And then we the where is ID equals to 11. Alright. Settle. Nice. Can we finish this today? I wonder. When you need to delete data from a table in the database, you can use, okay, this is the lesson 15, deleting rows. You can use a delete statement which describes the table to act on the rows of the table to delete through the where clause. Okay, delete from what table and what row? The whole row will be deleted, I guess. If you decide to leave out the where, all rows are removed. Whoa. That is very dangerous. Delete what row? Like the update statement from last lesson, it's recommended you run the constraint in a select query first, ensure that you're removing the right rows. Without proper backup or test database, it is downright easy to irrevocably remove data. Alright, the database needs to be cleaned up a little bit. Try and delete a few rows in the task below. This database is getting too big. Let's remove all movies that were released before 2005. Before 2005. Let's do it. Although I say that we should try to make the constraint from select first, right? It's here. Extra care, but you know, we are still learning. We should try it head first. Okay, where the year is less than 2005. Let's go. Oh, we don't have. Okay. Let's go. Incomplete SQL query. Why? Year is less than 2005. Delete movies where year is less than 2005. Why is it incomplete? Why is it incomplete? We shouldn't put a string, right? Because this is not a string. I think it's not a string. I think this is a number. It's an integer. So why? Not sure. Oh, delete from. Let's see. Alright. Andrew Stanton has also left the studio, so please remove all movies directed by him. What? Who? Andrew Stanton. This one. Delete from movies where director equals or like Andrew Stanton. Andrew Stanton. Okay, so creating tables. When you have new entities and relationships to store in your database, you can create a new database table using the create table statements. Okay, create table statement with optional table constraint and default value. Create table if not exists my table. Oh, if not exists my table. Such a linear table is defined by its table schema, which defines a series of columns. So this is the schema. The column has a name, type of data allowed in that column, an optional table constraint, and values being inserted, and an optional default value. The column and the data type, table constraint, and default value. If there already exists a table with the same name, the SQL implementations will usually throw an error. So to suppress the error and skip creating a table if one exists, you can use the if not exists. I see. Do not create an error. Table data types. Different databases support different data types, but common types support numeric, string, and other miscellaneous things like dates, booleans, binary. Alright, integer and boolean. Count, age, boolean, integer of 0 and 1. Float, double, real. Numerical data measurement. Okay, this is the more expensive more lengthy numbers. Character for variable character, text. This is a string, right? String, text, and all sorts of locals. Various type generally amount to underlying efficiency of the database and working with this column. Both the character and variable character types are specified with the max number of characters. Okay. Can be more efficient to store. Yeah. Date time. It can be tricky to work. Block. What is a block? These values are often opaque to the database, so you have to study with the right metadata to requery them. Binary data. Blocks. I don't know what is that. We are going to dive too deep into table constraint this lesson, but each column can have additional table constraints on it, which limit what values can be inserted into that column. This is not a comprehensive list, but will show a few common constraints that you might find useful. Primary. The values in this column are unique, and each value can be used to identify a single row in this table. This is the ID. Auto increment. Again, because it's primary key that connects two tables, like in a join. Auto increments. Value is automatically filled, incremented with each row insertion. Not supported in all databases. Okay. Unique. Values in this column have to be unique, so you can't insert another row with the same value in this column as another row in the table. It doesn't have to be a key. This must be unique. This is a key and it must be unique. This is just unique. This is an automatic things. Not null. Cannot be null. Yeah. Check. To run a more complex expression to test whether the values inserted are valid. Oh. You can check that values are positive or greater than something, or start with a certain prefix. Alright. Foreign key. This is a consistency check which ensures that each value in this column corresponds to another value in a column in another table. Wow! If there are two tables, one listing all employees by ID and another listing their payroll information, the foreign key can ensure that every row in the payroll table corresponds to a valid employee in the master employee list. Here's an example schema for the movies table that we've been using in the lessons up to now. ID integer is a primary key. Title, text. Oh, I see. This is the table constraint. Okay. This is the default value. Okay. If we want to have one. Title is a text, title is a text, here is an integer, length minutes is an integer. In this exercise, you need to create a new table for us to insert some new rows into. Wow. Create a new table named database. How do we create table? Okay. We create table by typing create table. Name database. With the following columns. We have name, which is a text, preferably in capitals because it's a keyword. A string, shall be the name of the database. Version, which is a number. It's a floating point, so just type float of the latest version of this database. Float, yeah, float. Download count. Download count. An integer. Count of the number of times this database was downloaded. This table has no constraints. Nice. That's it? I think that's it. No such table database. Create table. Yeah, let's go. Where does this come from? It doesn't matter. Altering tables. As your data changes over time, escape over a way for you to update your corresponding tables in database schemas by using the alter table statement. Add, remove, or modify. Adding columns. The syntax for adding a new column is similar to the syntax when creating new rows in the create table. You need to specify the data type of the column along with any potential table constraints and default values to be applied to both existing and new rows. In some database, MySQL, you can even specify where to insert the new column, in the first or after. This is not a standard feature. Okay, alter table, add column, data type, option selection. Oh, what is that? Removing columns. Dropping columns is as easy as specifying the column to drop. However, some databases don't support this feature. Instead, you may have to create a new table and migrate the data over. Column to be deleted. Table drop. This one, add a column with the specification. Renaming the table. If you need to rename the table, you can also do that using the rename to. Alter table, rename to. Everything starts with alter table in the name of the table. Other changes. Each database implementation supports different methods. Always best to consult your database docs before proceeding. Okay. Our exercise, adding new column, so give that a try below. Okay. What is the first thing that we need to write is alter table. Without reading the question, you just write alter tables movies. Okay. Add a column named aspect ratio with a float data type to store the aspect ratio each movie was released in. Alter table movies, and then add the name of the column. The name of the column is aspect ratio with a data float. That's it. Yeah, that's it. Right. Nice. Add another column named language with a text data type to store the language that the movie was released in. The default is English. Okay. So the same syntax. Alter table. Wait, what is happening? Alter table movies. Then we are going to add language. Is that the right way of spelling language? G-U-A-G-E-L-N-G-U-A-G. Alright. Language with text. And then we have the default and English. Default is string English. Yeah. Do not forget the double quotation. Okay. Everything is English. Nice. Because that's the default. Okay, the next one is dropping tables. Wow, this is the second last lesson. Yeah, I think we can finish this today. Okay, so the second last lesson. Lesson 18, dropping tables. In some rare cases, you may want to remove an entire table, including all of its data and metadata. And to do so, you can use the drop table statement. Differs from delete. You also remove the table schema. Drop table means it completely remove it. Delete, just delete the data. But this one, it also delete the table schema. Yeah. Like the create table statement, the database may throw an error if the specified table does not exist, and to support the error, you can use the if exists. In addition, if you have another table that is dependent on columns in the table you are removing, foreign key, then you have to either update all dependent tables first to remove the dependent rows or to remove those tables entirely. If not, then maybe we cannot. Maybe it will throw an error, right? If we are trying to remove a table that have dependency. We have reached the end of our exercise, so let's clean up by removing all the tables we have put with. We have sadly reached the end of it. Let's clean up by removing the movies table. Deleting the movies table. How? Drop table if exists. Yeah, I know it exists. So we don't have to put if exists. Movies. And drop the box office table as well. Box office. Alright, that's it. And that's it. You have finished the tutorial. We hope the lesson will be more experience with SQL, be more confident to use SQL here on data. We have just brushed the surface of what SQL is capable of, so to get a better idea of how SQL can be used in the real world, we will be adding more articles in the more topics part of the site. If you have the time, we recommend that you continue to dive deeper into SQL. If you need further details, we recommend that you read the documentation. Any suggestion? Alright, that's it.